Day 1, solving quadratic equations by factoring. After today, you will be able to solve a quadratic equation by factoring. Please remember that a quadratic equation can be written in standard form ax squared plus bx plus c is equal to 0, where a, b, and c are real numbers and a can never equal 1, or can never equal 0. If a equals 0, it would be a linear function and no longer a quadratic. What does the graph of a quadratic function look like? So remember, the graph of a quadratic function looks like a U. Recall, if we have the quadratic function x squared minus x minus 6, let's take a look at the graph. So when we have this quadratic function, what do we notice? Well, we notice that there is a 0 at negative 2, 0, and I also notice that there is a 0 or an x-intercept at 3, 0. What do you recognize? Well, we know how to factor x squared minus x minus 6. When we write our factors, x times x is x squared, 3 times 2 is 6, and in order to get a negative 6, I can put a negative 3, a positive 2. When I check that, x times negative 3 is negative 3x, 2 times x is 2x, and when I add those together, I get negative 1x, which matches, so I know those are my factors. So when we use the zero product property, if the product of two quantities equals 0, at least one of those quantities is equal to 0. So if A times B is equal to 0, then either A has to equal 0 or B has to equal 0. So when we use the zero product property, we are going to set both of our factors equal to 0 and solve. X minus 3 equals 0, x plus 2 equals 0. You use your inverse operation, so you add your 3 and get x is equal to positive 3. Inverse of positive 2 is negative 2, and you get x is equal to negative 2. When you use the zero product property, so set A equal to 0 and B equal to 0, use your inverse operations to solve for x. X is equal to 0 is completed. The inverse of positive 1 is minus 1. The inverse of multiplying by 2 is dividing by 2. And we get x is equal to negative 1/2. So when we solve by factoring, we are solving for our x-intercepts or our zeros. So we first want to make sure that our quadratic is in standard form. After it's in standard form, we move to step 2 and we factor. So we ask ourselves, what multiplies together to get x squared? X times x. What multiplies together to get a negative 12? 6 times 2. I want a positive 4 in the middle, so I'm going to make my 6 positive, my 2 negative. When I check my answers, I get negative 2x plus 6x, which equals a positive 4x, so I know my factors are correct. Step number 3 is to set each of your factors equal to 0 using the zero product property and solve for x. The inverse of negative 2 is plus 2, so I get x is equal to positive 2. The inverse of positive 6 is negative 6. And then when we write our solution, we write it in a fancy little squiggly. And our zeros, or our x-intercepts, are negative 6 and 2. So let's solve the next quadratic equation. So looking at this quadratic equation, the very first thing I do when I factor is I want to look for a GCF. In example A, they both have an x in common, so I'm going to factor out an x. 7x squared divided by x is 7x. Negative 4x divided by x is negative 4. I then am going to use my zero product property and set each factor equal to 0. Then I'm going to solve for my x's using inverse operations. 7x equals 4. The inverse of multiplication is division. X is equal to 4/7. So my x-intercepts are 0 and 4/7. Remember, x-intercepts we can also write as ordered pairs. When we look at example B, we notice that 4 is a perfect square and so is 25. So when I have the difference of two perfect squares, and I factor, I'm going to have 2x plus 5, 2x minus 5. Both of those parentheses are factored completely, so I'm going to set them each equal to 0 using the zero product property and solve for my x-intercepts. The inverse of plus 5 is minus 5. The inverse of multiplication is division. So one of my zeros is negative 5/2. On the other side, the inverse of minus 5 is plus 5. The inverse of multiplying by 2 is dividing by 2. So my two x-intercepts are negative 5/2 and 5/2. Moving on to example number 4, make sure, step number 1, we need to make sure our quadratic is in standard form. So to get this quadratic in standard form, I need to move my 10 back to the left-hand side of my equation. I use my opposite operation. So I subtract it, then I'm going to factor. What two things multiply to get 3x squared? So I have 3x and x. What two things multiply to get negative 10? So I have, my choices are 1 and 10, or 2 and 5. Going to try 2 and 5. I need a negative 10, so I'm going to choose to make my 2 positive, my 5 negative. When I check this and distribute this out, I get 3x squared minus 15x plus 2x minus 10. Negative 15x plus 2x is negative 13x, so I factored correctly. After you check to make sure if you factored correctly, you set each of your factors equal to 0, and you solve for your x-intercepts. The inverse of plus 2 is minus 2. The inverse of multiplication is division. So one of my x-intercepts is negative 2/3. The other x-intercept is positive 5. Place your smaller number first in your notation, your larger number second, and you just solved the quadratic equation. So you can solve a quadratic equation by factoring. Okay, the first example is it's already in factored form, so you just need to apply your zero product property and set each of those factors equal to 0 and solve. So you get x is equal to 6, 3x equals negative 5, x is equal to negative 5/3. Write your smaller number first, negative 5/3, then your larger number. The second thing is you need to factor. So when we factor, what times what multiplies to get 3x squared, 3x and x. What two things multiply together to get a positive 6, 2 and 3. In order for my first sign to be negative, second sign to be positive, both of my factors need to be negative. When you set those equal to 0 and solve for x, you would get 2/3 and 3. Make sure when you solve by factoring that you get your quadratic set equal to 0. So you may need to rewrite it in standard form. Then factor x minus 5x plus 3. Then use your zero product property to solve. So your factors are -3 and 5. Then we have a little bit trickier one. If you have two factors set equal to a whole number, you need to distribute this out first. So x squared minus 2x minus 5x plus 10. Combine your like terms, so move your 4 by the inverse operation. X squared minus 7x plus 6 equals 0. Then you have a quadratic equation. You can factor that. -6, -1. Set each of those factors equal to 0 using the zero product property. And your x-intercepts are 1 and +6. So please don't forget you can solve any quadratic equation by factoring. You must make sure it is in standard form, then set it equal to 0, factor, and apply the zero product property. If we are looking at a word problem that says the height in feet of a diver above the water can be modeled by h of t, which means y, is equal to -16t squared plus 8t plus 8, where t is the time in seconds after the diver jumps off the platform. Find the time it takes for the diver to reach the water. We can still find this by factoring. So when we have our quadratic equation, we want to first look to see if there is a GCF. So we can divide all of these or factor out an 8, and we're left with, we're going to factor out a -8. -8's on the outside, so we're left with 2t squared minus 1t minus 1 equals 0. We can then factor that quadratic. 2t times t is 2t squared. 1 times 1 is 1, but we want to make sure we get a -1. Set each piece equal to 0 using the zero product property. -8 equals 0 does not make sense, so we cross it out. The inverse of +1 is -1. The inverse of multiplying by 2 is dividing by 2. So we get -1/2 of a second. And we get the time is equal to 1 second. -1/2 of a second does not make sense because we're talking about time. So we are going to use t is equal to 1. And we can say it takes the diver 1 second. Why must one side of the equation be set equal to 0? Because any time you have 0 is equal to 0, one of your a or your b is equal to 0. What type of quadratic trinomials have only one solution? Those would be perfect square trinomials. And now you can complete your worksheet for day 1.